Assalamualaikum and good morning. I am MOHAMAD NAZMI bin YUSRI. Will present the research project entitled Warehouse Worker Simulation in Logistic Environment. I am going to start with the research problem. Firstly, there are no standard model that portrays workers' near-realistic movement in a warehouse. Most of them only focus on the simulation model to improve the warehouse operation, but not on the warehouse workers simulation. The other problem is the existing simulations are too generic because they lack parameters that affect worker behavior in the warehouse. The previous simulation mostly standardized worker movement, even though they are doing a different type of task, and there are no simulations that differentiate the workers' movement. Next is the research objective. The first objective is to develop a simple but effective simulation focusing on the warehouse workers, and secondly, to evaluate the effectiveness of the simple simulation by using some experiments focusing on the workers of the warehouse. For the methodology, there are three main phases, which consist of simulation model development, discussion, and conclusion. The simulation model development will be, of course, focusing on the warehouse workers. The focus will be on 5 workers, which consists of unloader, acceptor, transferer, controller, and loader, with some parameters involved, which are the speed of the workers will be different from each other, 2 types of routes for the workers to move, and the presence of obstacles in the workers' path. The expected deliverable for this project is a simple but effective warehouse simulation that incorporate those parameters so that the movement of workers can be observed. This is the implementation part. The simulation system will be developed using ChromoSim, a Python library specializing in microscopic crowd motion simulation. ChromoSim is chosen to be the one to implement this simulation because of the models provided by them can be integrated and adapted for warehouse simulation involving warehouse workers. This simulation is based on the previous 5 workers. Different number of workers will be used for the simulation, which are 5, 10, 50, and 100 workers respectively. The workers will have the same speed for first simulation, then the speed will be changed according to the type of workers. The speed of unloader, transferer, and loader is set at 1.25 meters per second, as that is the usual speed when someone is slowing down. Acceptor and controller are set at 1.5 meters per second because that is the average walking speed of a human. 2 routes will be used, which are unidirectional and bidirectional. The simulation will be conducted in 2 situations, path with obstacles and secondly, obstacles-free path. This is the simulation of the workers inside the warehouse. Like before, there will be 2 routes, which consists of unidirectional, which means 1 exit, and bidirectional, where there are 2 exit points. This is the graph generated from the simulation. This graph shows the time taken for the workers to move until they reach the exit points. This graph is for the unidirectional route, where the first one here is without obstacle, while this one here is with obstacle. While these two graphs are for the bidirectional route. From the simulation, it is found that the workers in the bidirectional route move faster than the workers in the unidirectional route. Moreover, the time taken to move inside the warehouse also slightly increases when obstacles are in their way, especially in the unidirectional route. This could be caused by minor collision between the workers and the obstacles. Greater number of workers could also increase the collision, and some of the obstacles were also placed near the workers' destination, blocking their movement towards the exit. Besides, the groups of workers set with constant or fixed speed display almost the same or slight differences in the time taken, while workers set with different speed show results where the time took for the workers' movement are different. The difference in speed of the workers is essential to mimic the real movement of the warehouse workers. Lastly, in both unidirectional and bidirectional routes, 5 workers per group display the lowest time to reach their destinations, while 100 workers took longer to get to the exit. The impacts and benefits for the study. Firstly, this research study could maybe help optimize the warehouse's operation by increasing the workers' productivity. Next, it could also help in the continuous improvement processes, since the process is viewed in a virtual environment. This can be used in a physical setting later. Lastly, it could help in optimizing the cost. With a simulation, designers can create an effective product in a virtual environment rather than a pricey prototype. Now I'm going to show the simulation for 10 workers in a unidirectional route with no obstacles. Now I am going to show the simulation in a bidirectional route with 100 workers in an obstacle path.